the last lesson, we looked at evaluating expressions with a single variable. Today, we'll practice evaluating expressions that have more than one variable. So let's get started. Whether dealing with one variable or more than one variable, the process is the same. Whatever the variable is, so in this case, we have a variable x, we're going to replace it with the given value. So in this case, 3. And then whatever y is, we will replace it with the given value for y, which is -4 in this example. So all the x's become 3's, and all the y's become -4's. We will then use order of operations, or PEMDAS, to simplify down the expression. In this case, we get -11. So this expression, x plus 3y minus 2, has a value of -11 when x is equal to 3 and y is equal to -4. So let's practice a few. For these 3 examples, we're going to use the same values for the variables x, y, and z. So in all 3 cases, x will be equal to 4, y will be equal to 5, and z will be equal to 10. So for problem 1, wherever there's an x, we will put a 4. Wherever there's a y, we'll put 5. And wherever there is a z, we will put 10. That leaves us with 4 plus 5 minus 10. 4 plus 5 is 9. So we have 9 minus 10. And then that comes out to -1. For the second problem, we have 4 minus y divided by z. So we have 4 minus, so the value for y is 5, and the value for z is 10. Let's start with simplifying this fraction. They both contain the factor 5, so this is 5 times 1 in the numerator, and 5 times 2 in the denominator, so we can cancel out those 5's. So that's going to leave us with 4 minus 1 over 2. We simplified down that fraction. So we need a common denominator. In this case, the common denominator will be 2. So that will be 8 over 2 minus 1/2. And then we do the arithmetic. 8 minus 1 is 7, and we keep that common denominator. So the answer is 7/2. Or we can write this as 3 1/2, or 3.5. And then finally, we have negative, and then our x value is 4, y value is 5, and z value is 10. So that gives us -4 times 5 is 20, all over 10. And this simplifies down to -2. Let's look at 3 more cases. For these cases, x will be equal to 3, y equal to 4, and z equal to 0. So in the first case, we have x times y plus z. So x becomes 3 times y, which is now 4, plus z, which is 0. 3 times 4 is 12, so we have 12 plus 0. When we add 0 to anything, the anything just comes out. So in this case, it's 12. Next, we have 2x divided by z. So 2 times x, x is 3, all over z, which is 0. 2 times 3 is 6, so now we have 6 over 0. And we're dividing by 0. Thou shalt not divide by 0. So in this case, our answer is undefined. Or we could say it's meaningless because we have division by 0. So for this particular expression, it has no value when z is equal to 0. It's undefined at that value. Now let's look at this last problem. And we have negative z times the quantity x plus y. Let's solve this in the way we've been solving the previous problems, in that we're going to substitute the values for each of the variables into the expression. And that'll give us negative z, so negative 0, times the quantity x plus y. So 3 plus 4. And now we have negative 0 times 7. But what is negative 0? Let's look at this problem in a different way. So here we have negative z times the quantity x plus y. We could rewrite this as negative 1 times z times the quantity x plus y. And when we evaluate for those values for the variables, we'll have negative 1 times 0 for z times x plus y. That's 3 plus 4. And then using PEMDAS, we're going to have negative 1 times 0 times 7. And then negative 1 times 0 is 0. We have 0 times 7. And then anything times 0 is 0. So 0 times 7 is 0. Again, this is the same thing we have here. So we can view this negative 0 as negative 1 times 0 times 7. And again, that will give us 0. A great way to learn is to practice on your own. We will discuss in a bit, but go ahead and pause your screen and do these 4 problems. So for these 4 expressions, we will evaluate when x is equal to 6, y is equal to negative 2, and z is equal to 5. We will replace each of the x's with 6, so that gives us 4 times 6. The y will be replaced with a negative 2, and the z will be replaced with a 5. Following PEMDAS, we will do the operations within parentheses first. So negative 2 plus 5 is 3. And then we'll multiply from left to right, giving a final answer of 72. For the second problem, we have 3y over the quantity 2x minus 3z. Again, wherever there's a y, we'll replace with a negative 2. Where there's an x, will become a 6. And z's will have a 5 value. Just a reminder, as you do PEMDAS, items above the division bar can be viewed as being within a set of parentheses. That is one grouping. And the items, the operations below the division bar, are also viewed as a second grouping. So we'll do everything on top first. 3 times negative 2 is negative 6. And then what's on the bottom? 2 times 6 is 12. Negative 3 times 5 is negative 15. And then 12 minus 15 gives us negative 3. Negative 6 divided by negative 3 is 2. Once again, we will substitute the values for x, y, and z into the expression, and then simplify using order of operations. For the first expression, that gives us negative 8. And then for the second expression, doing the same process, we end up with 28. Notice the difference between these two expressions. In the first case, we have x plus y times the quantity z plus 2. Only one set of parentheses enclosing z plus 2. Only y is multiplied to z plus 2. For the second expression, x plus y is enclosed within a set of parentheses. So it's x plus y that is multiplied to z plus 2. And that one extra set of parentheses matters. We do get a different answer. Continue practicing evaluating algebraic expressions, and I'll see you in the next video.